some of these lecture notes, you'll see it up at the top, it'll say college prep math, okay, but it's 1050, okay. When I was at Itinerus, we taught a class called college prep, and that was for kids that, for students that took 1010 and like only passed it with like a C or something like that, so they needed some help before they went on to 1050, and that's what this is. But these are straight from the 1050 book, so they will translate very well. So it says college prep up top. Don't freak out. Now if it says 1010 like last time, freak out, because then I've screwed up. So, but if it says college prep, then we'll be okay. All right. All right. Let's roll. So today we're going to talk a lot about functions. Okay. And again, hopefully most of this is review for you guys. But a function is just simply a mathematical rule. It takes a number expression, you plug it into the function, it does some magic math on it, and then it spits out your answer, okay? Now, the first thing we want to talk about is function notation, okay, to make sure that we understand. Okay, so we all understand what that is right there, correct? That is, how is that read? F of x, right? It doesn't mean f times x or anything, it's just f of x. It's a function notation, okay? Mary, check that, Mary, check the thermostat and see what it's set at. If it's like, get it down to about 71, if you would please, if it's not there. Yeah, it defaults really high for the weekend, so thank you. We'll cool this down. All right, yeah, so that is read f of x, and f of x is the same as y, okay? So again, so y equals f of x. They are the same thing. F of x, okay. All right, so now we want to talk, now do we understand functions, right? So who can define a function for me? Or just give me some general idea that you have about a function. Why do we call certain relations functions or certain equations functions? What's special about functions? Okay, keep coming. Keep coming. You're all close. For every x, there's one y, and only one y. That's the key to a function, right? And we'll talk about it later, but a function has to pass, if we have the graph of a function, it has to pass what test? The vertical line test, right? Is all this coming back now? Remembering this stuff? Okay. All right. So we want to determine whether this is a function or not. Okay, x squared minus 3. Okay, so what we're going to do now is we're just going to do a little xy table to begin with, and then we'll kind of go from there. So if x is negative 2, what does f of x become? Yeah, negative 2 squared is 2, minus 3 is 1. Good. If x is negative 1, what is f of x? Negative 2. 0? 3? Good, because 3 squared is 9, 9 minus 3 is 6, and what if x is a? A squared minus 3. Okay. All right. So, now the set of numbers that we plug in, all right, or our x values, is called the domain. Okay, you've probably also heard it's your independent variable. Okay, because we can make x what we want in a function. Okay, the stuff that comes out, or the y's, or the f of x's, that is our range, okay? Okay, and again, since we usually pick the x's, we plug in. The x's are the independent variable. Put down here, so x, oh, try to go straight up and down. X's are the independent variable, and y's are the dependent variable. How a function works, okay? So a couple of them are, for every x, each x corresponds with only one y. For every x, there's one y. For every element in the domain, or member of the domain, I guess is how to put it here, okay, there is one member of the range, or one element of the range, okay? Now, functions don't always have to deal with numbers, okay? Now, generally for us, yeah, they're numbers, right? But they don't have to be. For example, birthplaces of all students in Math 1050, okay? So, So everybody here was born, correct? I'm assuming, right? I think I'm pretty safe with that. I don't know, some of you, I wonder. But anyway, okay? Now, where were you born? Okay, so how many were born in the state of Utah? Raise hands. I'll raise my hand because I was born. Okay, mostly, how many were born outside of Utah? Okay, how many of you were born outside of the United States? Okay, one of us? Okay. All right. So, let's talk about it now. So, is this a function? Okay, is what we just talked about a function? Okay, is for every x, is there only one y? So for every one of you, is what I'm asking, were you born in one place? You were, right? Now some of you were born in the same place, correct? Okay, like a lot of you were born in Utah. Okay, or we could even make it smaller, but that doesn't matter. Each of you were only born in one specific place, so therefore that is a function. Okay, for each x, your each input, there's only one output, and that's where you were born. Okay? So again, functions don't always have to be about numbers. Okay? But that being said, it's mostly going to be about numbers for us, right? So let's look at example 3 here. Okay? So let's make a list of our domain and range and then determine whether or not it's a function. Okay? So for example 3 here, what is our domain? And again, domain is your x values, correct? So domain is -4, 0, 1, 2, and 3. Okay, now what is our range? Our range is 3, 4, -1, 1, and then 3, but we've already got 3 in, so we don't have to write it twice, okay? Now, one way to determine if a relation is a function is called mapping, okay? So we put our domain and range in these boxes. Now we just draw little arrows that correspond to each one, okay? So for example, -4 corresponds with 3, 0 corresponds with 4, 1 to -1, 2 to 1, and 3 to 3. Okay? Excuse me. So is that a function? And the answer is yes. Okay? Each x has only one y. Now, two of the x's have the same y. There's just like some of you, more than one of you are born in Utah, but there's only one element, only one part of the range that matches up with each part of the domain. So is this a function? And that is yep. That is a function.
Yep.
Yep. So now the question is asked, what if we added the point 1 and 3 to the set above? Would it still be a function? Okay, so if we do our mapping, so we go from 1 to 3, it's not a function because of that right there. Okay, because 1 goes to two different parts of the range, right? It goes to 3 and it goes to -1. So that would be a big old nope. Okay, so example 3 star here, that's just what we talked about. Okay, so we added this point, okay, to our relation, and it is not a function anymore. Okay, because when x is 1, y can be two different things. It can be 3 and it can be -1. If that's ever the case, if two y's correspond with one x, it's not a function. Okay? Okay, so now again, so we're sort of talking here about, all right, the functions must pass the vertical line test. We already talked about that. Okay. So on the left here, let's draw a graph that is a function. So knock yourself out. Draw some graph that's a function. Okay, you can have tons of different ones. I'm gonna do something similar to a cosine wave. Okay. Goofy as that is, that's a function. Okay? Because it passes the vertical line test. Okay? So in other words, for the vertical line test, it doesn't matter where, I just draw random vertical lines. And if my graph only touches every vertical line once, then it is a function. Okay? So let's draw something that's not a function. Bless you. A nice perfect circle like that is not a function. Okay? Because if I draw a vertical line right here, my circle touches it twice. Okay, something like this. Not a function. Okay? Because this vertical line goes through it, goes through the graph twice. Okay? Does that make sense? So for vertical line test, pretty easy stuff, right? All right, now, it's easy to tell if from a graph, whether it's a function or not, right? But what about an equation? It's a little harder, but it's still doable. Okay, so y equals x squared. Is that a function?
Yeah.
What do you think? Yeah, and if you're not sure if it's easy enough, just graph it. Okay? But we're going to talk about some other methods eventually on how to determine whether they're functions or not. So is this a function? Yeah. Because there's your y equals x squared, so that's a yes. Now, x plus y squared equals 25. Is that a function? Okay, kind of screwy, huh? But we can also, you can either solve this for x or solve this for y and then plug stuff in. But you will determine that is not a function.
Yeah.
X squared plus y squared equals 4. Is that a function? What is that a graph of? It's a circle, right? Are circles functions? No. And I will tell you this, pretty much any graph where you see a y squared, it's not a function. The only exception to that is if they restrict the domain, okay? So like if we have, for example, let's just say x equals y squared, okay? That function will look like this, or that graph will look like this. But if I restrict my, you know, I can restrict my y values and say y has to be greater than or equal to 0. Okay, and if that's the case, then this can go away. Now I have a function. Okay, but that's a little complicated. We'll get into that stuff later. But yeah, so pretty much anytime you see a y squared, you're not going to have a function. Okay. All right, so we're given that g of x is 5x minus 1. So if I want to find g of 4, what do I do? Yeah, plug 4 in for x, right? Don't make this hard, people. So what's g of 4 in this case? It is 19. Good. What's g of negative 3? Negative 16. What's g of a? 5a minus 1. Good. What's g of a plus 1? That is 5 times a plus 1 minus 1. Or we get 5a plus 5 minus 1, or 5a plus 4. Okay, now be careful notationally. All right, part E, g of a plus 3. What does that equal to? What's g of a? 5a minus 1 plus 3. So we get 5a plus 2. Okay. So be careful with the notation. If the number's included in the parenthesis, then that is substituted in for x. If it's outside of it, then that's added on to the end. Okay? So please make sure. All right, part F, g of x plus h. So that means I get 5 times, instead of x, it's x plus h minus 1. So it gives us 5x plus 5h minus 1. Okay, now you will see some, and I think it's on your homework assignment, where you'll be given something like that, and it'll ask you to find like g of x plus h minus g of x. Okay? So you plug that in, and then simplify it. Okay? Okay, so there's 3 types of functions that have domain issues. Okay, where domains can kind of screw us up. What do you think they are? Okay, where if x is a certain value, then it's bad. Or we have to restrict domains. Okay, we've already talked about one of them, right? When you have a y squared. Okay, that's one of them. Okay, another one is where you have a 0 denominator, or you have x's in the denominator. Okay, and another one is square roots. Right, because x is not defined everywhere under a square root, correct? In the real numbers. Okay. So those are our domain issues. When the y is squared, when your denominator can become 0, when there's an x in your denominator, and if we have square roots. All right, so let's look at some of them now. Now on example 6, we want to find the domain of each of these. Okay, so our function here has to be defined everywhere. Okay, so if we look at part A, where is our function going to be undefined? When x is 6, right? So your domain then, and you can put it this way, x can't be 6. Now, MathXL will probably have you put this in interval notation. Okay, that's interval notation, right? Yeah, so it's this. So interval notation is this, from negative infinity to 6, comma, and then union with 6 to infinity. And those are all parentheses, they're not brackets, okay? Because brackets means that they're included. Okay, part B. What's our domain? What can't x be? X can't be 3. What about 0? 0 okay?
Yeah.
Absolutely. Numerators can be 0, that's fine. Denominators can't. So just x can't be 3. All right, part C. What can't x be? What's going to make that undefined? You are correct. For once, your silence is good. There's nothing that's going to make that undefined. Okay? So there's no restrictions on our domain. So what does that mean? My domain is? Right, all real numbers. Negative infinity to infinity. Okay, let's look at part D. Okay. So 7 over the square root of 6 minus x. So what can't x be? X can't be bigger than 6, right? Now, can x be 6?
Yeah.
Okay.
No, because that would be 0.
Right. Now, for the square root purpose, it can. The square root of 0 is 0. That's defined. But if my denominator becomes 0, that's bad, right? So in this case, x can't be 6. So my domain is from 6. Oh, that is a parenthesis, not included. From 6 to, no, other way. That's what it can't be. It can't be from 6 to infinity. Sheesh. So my domain is from negative infinity to 6, non-inclusive. All right, part E, x over x squared minus 9. X can't be what? 3 or negative 3. Good. So x cannot be plus or minus 3. Now again, interval notation, that's takes forever. From negative infinity to negative 3, and from negative 3 to 3. Oops, forgot my union sign. And from 3 to infinity. Okay. All right, part F. X over x squared plus 9. What's going to make that undefined? What do you think? And again, you're correct. Your silence is just awesome. Yeah, there's nothing's going to make that undefined. Because that square is going to make everything positive down there, so a positive number plus 9 or a non-negative number plus 9 always works. Now, with functions, we can also add, subtract, multiply, and divide them all. Okay? And it's pretty simple. So if we have f of x is 3x plus 4, and g of x is x squared minus 3x plus 1. Let's do f of x minus g of x, okay? So that's 3x plus 4 minus, parenthesis, x squared minus 3x plus 1. Now, you just have to be careful here that you distribute that minus sign to everything in this parenthesis here, okay? So this ends up 3x plus 4 minus x squared plus 3x minus 1, okay, which gives us negative x squared plus 6x, 4 minus 1 is 3, plus 3. So there's your answer there. Okay. And this one now, g of x over f of x. Now watch this. It's kind of tricky, but I think you can get it. No, we're done. Just write one over the other one. You're done. Now, we'll get some others when we talk more about rational expressions where we can factor and do some canceling and things like that. But for now, yeah, just stick the one over the other and you're good.